Today I'll be going over some of the basics of common base amplifiers, how they work, and the reasons for the low input impedance. And I'm also going to be trying out this new toy I got, so I'm pretty excited for this as well. Here's the schematic of the circuit we'll be taking a look at today. It uses a voltage divider to bias the base, with a bypass capacitor, so the base is essentially at an AC connected to AC ground. The input is at the emitter and the output at the collector. Now I want you to think about this as as an emitter follower that will keep a 0.7 volt, a 0.7 volt voltage drop from base to emitter. So if the voltage at this point is constant and you're feeding current into this node, it will decrease the current going through the transistor. If you sink current through this node, from this node, it will have to increase the current that goes through the transistor to keep the voltage at this node constant. Of course, there is some resistance inside of the transistor at the emitter, so the voltage that would actually be kept constant would be right here, not the output pin. This resistance will also add to the input impedance of the amplifier. And in this case, as I'm using relatively small resistors and I'm running a relatively high current through the transistor, I'll have a really low resistance. I'll have a really low dynamic resistance on the emitter. So I'm adding a 47 ohm resistor on the input to match the impedance of my signal generator. I'll also be using a capacitor to block the DC from going into my signal generator and messing things up. I also have a small little aside for the beginners out there who might not be familiar with the fact that your signal generator has an internal amplifier and a 50 ohm resistor on the output. This is to match the impedance of your average RJ58 coaxial cable that you might use to hook up a signal generator to a circuit. However, when you load your signal generator with a resistor of more or less 50 ohms, like I'm doing here, you'll essentially get a voltage divider which will have the voltage. I'll start by demonstrating the voltage divider effect caused by the 50 ohm resistor inside of the signal generator. I've set it to a 1 kilohertz sine, 1 volt peak to peak. And here's the oscilloscope on 500 millivolts per division on channel 1. As you can see, the output voltage is of 2 volts peak to peak. However, if I connect the 47 ohm resistor, it drops down to more or less 1 volt peak to peak. So a particular quirk of this Handtech signal generator oscilloscope thing is that there's no way to select the output impedance, the load impedance for the signal generators. So the set voltage assumes a 50 ohm load. So it's important to take into account that if you're having a high impedance load, it will be twice what you set. Now I have it set for 1 volt peak to peak, and I have a 50 ohm output impedance. So I'll set the oscilloscope to the input of the amplifier, actually to this point before the resistor, and it's set to 500 millivolts per division on channel 1. I'll move it up. and let's probe the output of the amplifier. Okay, these cables are a bit awkward. There we go. Channel 2 is set to 2 volts per division. So as you can see, the input is 1 volt per division. Sorry, 500 millivolts per division. So 1 volt peak to peak. And the output, I have it set to 2 volts per division, which is more or less 4 volts, slightly over 4 volts peak to peak. Which makes sense since the resistor here, R1, would be 220 ohms, and the load resistance here would be more or less 50 ohms. Slightly less, slightly more, but you will expect a gain of 4. Here's a better example with both channels set to 1 volt per division. Now, I also wanted to show you the voltage at this point at the emitter. That's 100 millivolts per division. It's significantly smaller than the voltage before the 47 ohm resistor. And it's in the order of more or less 100 millivolts, maybe. The measurement menu of this oscilloscope is not very good, to be honest. Less than 100 millivolts peak to peak on the emitter. But again, what drives the amplifier is the current. The voltage doesn't change much at the emitter.